Within 5G, we need to increase our data throughput to where we can support an upwards of 20 gigabits per second. So within this cell site, we'll be able to support many users, many IoT devices with their aggregate throughput approaching 20 gigabits per second. So the latency requirement in 5G is less than 1 millisecond of delay. And how that will be accomplished is through changing the air interface frame structure so that we can send data in a millisecond, half a millisecond, quarter millisecond, as little as an eighth of a millisecond over the air. This is very valuable for our real-time sensitive use cases. As with 2G, 3G, and 4G, spectrum is always going to be a challenge. We're not going to just be able to throw more spectrum at the problem to get to these 20 gigabit per second connections. So one of the challenges that we're having to solve within 5G is to be able to be more spectrally efficient than LTE. Specifically, we want to be 3 times as efficient as LTE Advanced. As our subscriber density, our device density grows, we still need to be able to handle a minimum throughput so that every device can have the throughput they need. Not only do we need to be able to support 10 megabits per second per square meter, we need to be able to support 1 million connected devices per square kilometer. Those connected devices could be some type of an IoT sensor, security camera, or a traditional subscriber. One of the other key applications of 5G is the uplink will be significantly faster. So we saw in 4G how our downlink speeds were good enough to do pretty much any video service that we wanted. But the uplink was challenged. Now in 5G, we'll be able to see a bump in uplink speeds. So if you're a camera crew that's trying to take some footage and send it up to a TV station, sending that up via a 5G network is going to be practical and a lot more cost effective than the way it was done in the past.